Welcome to this course on C programming with puzzles from in 28 minutes. Let's start with a question. How do you want to learn to drive? Do you want to sit at home, read about it, and watch somebody drive? Will it really work? I'm sure it wouldn't. Programming is very similar. We have created this course with a lot of hands-on examples, and what's more, we use more than 100 puzzles to illustrate advanced concepts. In this video, we will look at structures in detail.
Let's look at structures, different interview questions which are related to structures. Why do we need structures? How do you declare a structure? How do you define it? How do you initialize a structure? How do you pass a structure to a function? And what is this operator related to structures? And how do you create an array of structures? How do you dynamically assign memory to a structure? How do you deallocate memory from a structure? Let's look at all that and a little more in this particular video. Let's start. What is a struct? A lot of us studied geometry. In geometry, we have a x coordinate of a variable or a point and a y coordinate of a point. I can store it as two different variables. Let's say there are 5 different points. Then I would need to store as x1, comma x2, comma x3, comma x4 and x5. And similarly, I need to create the y1, y2, y3 and y4, y5 so that I can store 5 different points. I can make it easy by using an array, right? I can say x, I want to have an array of 5 and I want to have a y points of 5. But this way of organizing, this contains all the x coordinates for points and this contains all the y coordinate for these points. This way of organizing things is not really good because I would want to store the x coordinate and the y coordinate together as one point. Is there a way I can do that? That's where the structures come in. Structures help us to organize data in a much better way. If I want to create a structure, so x comma y makes a point. So I can create a structure called struct is a keyword. Point is the name of the structure. What does the structure contains? An integer called x and an integer called y. Probably if it's a point, even a char or a short suffices. I'll just use an int to make it very simple. So now we have declared a structure. This is what is called the declaration of a structure. Now I would want to define an instance of this particular structure. Defining is allocating memory. I'm really creating an instance of it. So the way you create that is by using struct point. I would want to create it as point1. So this is how you define a structure. So here a memory location to memory like a structure which is 4 or 2 integers amount of memory is allocated to this structure and it's called point1. I can also initialize this. How do I initialize this? By 1 comma 2. This is how I create a structure, define it, initialize it, and if I would want to print out the values of it, I can do that too. So printf %d, %d. I would want to take the values from point1. Point1 has two values, x and y, right? X and y. The way I access them is by using x.x, point1 dot y. X and y are called the members of the structure. The way you access the member is by using dot operator. So structure name or struct variable name dot the name of the member. Struct variable name dot name of the member. So name of the member. And now I can run it and you would see the output. So it's x and y. So now this enables me to store the points together. So if I want to store multiple points, I can create an array of points. So now I can create an array of points. How do I store an array of points? Is by creating an array. So now I can create an array. So I can say comma 1 comma 2 is 1 point. I would want to store another point comma 5 comma 6 and another one called 7 comma 8. So these are the 3 points that I'm storing in there, and now I can use any of them. So let's say I want to take the first statement, points of 0.x, points of 0.y. I can take the third element as well. So I'm looking at the third element right now. This is the third element in the structure. And when I run this, 7 and 8, that's the third element which is printed. So now you'd see that I can refer to points by points of 0, points of 1, points of 2, which is much better way of representing the structure than the one which we had, where we had 2 arrays or individual 10 variables to represent all this. While learning why we want to use structures, we also learned a lot of things. We learned how to declare a structure, how to define a structure, how to initialize a structure. Let's now move on to how to pass a structure to a function. So here I'm doing a printf of points 2. I don't want to do this. What I would want to do is I would want to create a function which does that. So I would want to print this in a function. So how do we define a function for that? So void print, and what do I want to pass to this structure? Usually if I'm passing an integer, I would say int x. So here I would want to pass a point element. So I will just call it point1. So I would want to pass a structure. What is it? A structure. So I say struct. What is the name of the structure? Point. So point is the name of the structure and point1 is the name of the variable, structure variable. So now I can use point1.x and point1.y. And let's format it a little bit. And now I would call this function. How do you invoke a function? By using its name. And what do I want to pass in? I want to print points of 2. So I would want to print the third point, 1, 2, 3, this point. So let's run this program and see if it runs fine. So you'd see that the third structure is printed. Now, because this function is there, I can easily print all the things. So print point of 0, print points of 1. So it would print 1, 2, 5, 6, 7, 8. I should have given a new line. So now I can give a new line as well very easily because it's in a function, just one place. That's it. So that's how you'd pass a structure to a function. We also looked at how to create an array of structures just now. So the way we create an array of structures was very similar to how we create an array of numbers. So instead of int here, we said instead of the name of the integer variable, we said the name of the structure variable and open bracket, close bracket. That's it. It was very simple. In this video, let's look at how to pass a structure to a function. And the second question we would want to try and answer is, are modifications to structures reflected back to the calling function? This is struct point. I'm creating a instance for it, p1, with values 1, 2. And I'm calling an increment function. The way you pass a structure to a function is very simple. Actually, while defining the function, instead of, let's say if it was an integer variable, it would have been something of this kind. Instead of that, you put the name of the structure and the struct keyword before it. You can use type def to avoid this, but for now, struct point p. And when you define the function, it's the same. So you define the function, and inside that you can access the members of the structure. So p is the structure which we are passing in, and we are doing p.x++, that's incrementing the x value in the structure in here, and we are printing the value in here. So in the main, we are initializing a point. We are trying to increment it in the function, and we are printing the value in the function as well as in the main. Let's see what happens. So if you see it, increment x, the x is incremented, so the value 1 becomes 2. However, when it comes back to main, the value of x is 1. That's because a structure is passed to the function by value. Let's understand this further by looking at how it's stored in memory. So when I declared a structure P1 is equal to 1 comma 2. The way it's stored in memory is P1 is created in memory, some memory location, it doesn't really matter. 1 and 2 are stored, and P1.x points to this, P1.y points to this, and P1 refers to the first address. So P1 would usually store the address of the first memory location, and X and Y would refer to the appropriate memory locations. So this is how it would be stored. When P1 is passed to the function, what would happen is the entire values of P1 are copied to another structure. So a new copy of the structure is created in that particular function. So P, if you look at it right now, points to completely different structure. So when the execution comes here, P would be active and this would contain a different values. The entire structure is copied and put in a different location in memory. And when I do p.x++, what is incremented is p.x++, so 1 becomes 2. And when I print it, that's the value which is printed. When the function completes, increment x function completes execution and returns back to the main, this entire thing gets deleted from memory. And all that is left is P1, which is still pointing to the old value of x. And it prints a value of 1. So as you see, all the calls to a function are by value. But what makes the difference is whether the value which is passed is the value of the variable or is the value of a address location, whether it's a pointer or whether it's the actual value which is getting passed. In the case of an array, the thing which is passed to a function is the address of the first location of the array. So what happens in an array is that any modifications in the function are reflected back to the array. However, in the case of primitive variables and in the case of structures, it's a little different. I hope this video helped you in understanding what happens when a structure is passed to a function, and hopefully it helps you in understanding this much better. Until next time. Now let's move on to structures and look at a few puzzles related to structures. So I have a small structure which is defined, struct point, int x, int y. It has two, it basically represents a point in geometry, x coordinate, y coordinate, x and y. And I'm creating an instance of that particular structure, p1, and I'm printing the values of p1.x, p1.y. So I'm basically not initializing anything. What would be the default values which would be printed? Think about it, pause the video, and come back. Let's run the program right now. As you can see, the values which are printed are garbage. So if you don't initialize anything, then the values which are assigned are garbage. Now let's try and initialize. So what would be the output of this particular program? This is the correct way to initialize, and what would be the correct output of this particular program? Okay, this is the correct way to initialize an array. So the way you can initialize an array is in this particular way. And let's say I am only initializing x. What would be the value for y? Think about it. I'm only initializing one value. I have two values in the structure. I'm only initializing one value. What would happen to the other value? The other value would be assigned a typical default value. So that's about the initialization of structures. If it's an automatic variable, it would not be initialized unless you are initializing at least one of the values. Then it would be initialized. The rest of the values would be initialized with a default value. And if it was an external or a static variable, it would have been automatically initialized. Now I'm removing this keyword struct in here. Will this program compile? And will this give, or will it give an array? Will it give an error? Let's run this program. Yeah, as you know, this is giving an error. So there's one way you can actually define a new type which would allow us for this program to compile. So what should I do? Think about it. So the puzzle is basically, now I don't want to change line 9, but I would want the program to compile. So how can I do that? One of the ways I can do that is by using a type def. So I could do something like type def struct point and point. So basically I'm defining a new type def, and when I run this program, as you can see, this program would compile. So wherever I want to use struct point, I can just use point here on. So this is a type def. Type def is a way you can create new types. You can probably even create a type integer and name it as something else. So type def helps us. Let's say you want currently store something as a int, and later point you want to change it as long. You don't want to use int everywhere in the program. So what you would do is you would, for that particular variable type which you want to be able to flexibly change from integer to long, you create a type def. And then at a later point in time, you change the type def declaration to point to a long instead of the int. So that's about the type def. Now let's move on. So this is your next puzzle. Try and guess the output of this particular puzzle. So P2 has the address of P1. So P2 is a pointer to a structure which contains address of P1. And I'm trying to do P2.x and P2.y. Will this program compile? Nope, this wouldn't compile. Actually, the way you need to make it compile is by using address of. So P2 is a pointer to a structure. So the pointer to the structure will not have something called .x. You need to get the value. So the value at P2 is what the structure is. So the value at P2.x and the value at P2.y. So this is how you need to get to the structure itself, and then you'd be able to get the values at P2 and P1, which are pointed, which are the values at the structure which is pointed by P2. Now, is there a simpler syntax? So what would be the output of this particular program that you are seeing on this? Let's run this. So you'd see the values of inside the structure being printed currently. So basically, the way you can look at it is this operator is a shortcut. This operator is a shortcut for doing this. Here I'm doing it on X, here on Y, but basically, if you look at the syntax, here this operator is the shortcut for doing a value at this and dot. So if you want to do, so this whole thing you can just replace by P2 this. So that's the pointer, structure pointer operator. I mean, this is the way you can get the values from a structure pointer. So this is very useful, I mean, because it's easy to understand. So then you are sure that P2 is a pointer. But if I'm doing something of this kind, what would be the output? So I'm, instead of using a structure pointer, I'm directly doing the pointer on a P1. What would be the output? Obviously, it would be a compilation error because this operator is only defined on pointers to structures and not on the structure side. So you have to change it back to the pointer to the structure, and then it would compile properly. So these are some of the things which are interesting, which are related to a structure, and we would move on now to the next puzzle. Now let's look at this program and try to guess the output of this particular program. So I have a structure point. I'm creating an instance of it, and I'm passing it to increment function and incrementing the values in there. So the question is whether the increment values would reflect in here or not. So would after print the changed values or would they print the actual values? That's the question right now. Think about it and come back. Let's run the program now, and you can see that before and after are printing the same values. So the values of X before and after are not incremented. So basically what is happening is the values which are changed in here are not being reflected in here. The reason for that is that in structures, when I pass a structure to a function, so this point one I'm passing here, it's called a P1. So this P1 I'm passing to a function. So what happens is a new structure would be created. So a new structure called P would be created where the values of the original structure are copied over. So 1 and 2. I'm incrementing now P.x plus plus, so this becomes 2, P.y plus plus, this becomes 3. And when the function finishes executing, these things go out of memory, or these things are not referred to anymore, and we come back to pointing to P1, and the P1 still has the original values 1 and 2. So that's how structures are passed. Structures are passed as usual. In C, everything is by value. So even if you pass a pointer, only the value of the pointer would be copied. So the value of the pointer would be copied to a new variable. So in C, everything is by value, whether you are passing a pointer or whether you are passing a normal value. So if you pass a normal structure, it's the value of the structure which is copied. If you pass address of a structure, the address of the structure is the value which is copied. So is the value which is passed. Now let's change this program to use a pointer and see if the changes would reflect in there. So what do you think the output of this particular program would be? So here I'm passing an address of the pointer. So I'm passing the address of the structure. I'm passing the address of the structure. I'm defining a pointer to the structure in here, and I'm incrementing the values in here. So what would be happening in here? What would be the output? So if you look at the output right now, it's 1, 2, and after you can see here that the increment happened. So p1.x before was 1 and now it's 2, and p1.y was 2 before and 3 now. So the value gets incremented because the way it's happening right now is p1 actually, if we look at it, is stored at 6000. What I'm passing here is not p1 but the address of p1. So what I'm doing is this p is not a structure anymore but actually the address of p1. So the address of p1 is 6000. So what I'm passing to the function is the address, that's 6000. So when I'm doing a p-x++, what it does is it takes the value at p.x. So value at p is 6000 dot x, which is 1. So the value 1 would be becoming 2. And when do p, so next the value of p dot y is incremented, and therefore you are actually modifying the structure which was originally defined, and the values would be reflecting in the main function. So those are kind of the important things that are related to structure.
If you are preparing for C interview, we have a complete C interview guide available. And if you are preparing for a C aptitude test, then we have C puzzles for interview as well. You can find the links to this in the description of this video. If you loved this video, then we are sure you'd love our other courses as well. We have more than 10 GitHub repositories with examples on C, Spring, Java, basic web application, Maven, Mockito. Whenever you are in need for examples, you can look these up. We have a number of courses created on ChalkStreet as well. You can search for in 28 minutes in chalkstreet.com, and there you go. Right now we have 3 different courses in here. I'm sure there will be a lot more courses and we have a lot of courses on C, Java, Spring, and a lot of Java related frameworks and web applications on Udemy as well. You might like some of the most watched videos on our YouTube channel. We have courses on design patterns, web applications, Maven, Spring, Eclipse, and web applications as well. Good luck with your learning. All the best for you. Until next time.